If x and y are positive integers and x is greater than y, what is the remainder when x squared minus y squared is divided by 6? Now, statement number 1 says that the remainder when x plus y is divided by 3 is 1. So x plus y is a multiple of 3 plus 1. Now, only using this statement, x and y can take many values. For example, if a multiple of 3 plus 1 would be 6 plus 1, 7, I could say that it's 4 plus 3, or 5 plus 2, or 6 plus 1. If I use 4 and 3, 16 minus 9, that would give me 7. Divided by 6, remainder is 1. If I use 5 and 2, 25 minus 4, that gives me 21. When you divide by 6, the remainder is 3. So you have at least 2 different answers. Not sufficient. The same would happen with statement 2. If I use x minus y is a multiple of 2 plus 1. Okay, let's just say that this could be 5, for example. And x and y could be 6 and 1. Okay, if it's 6 and 1, 6 minus 1 is 5. 36 minus 1 is 35. Divided by 6 is 5. Remainder 5. If I use 7 and 2, then you would have 49 minus 4. That would be 45. Divided by 6, the remainder is 3. So again, 2 answers, not sufficient. Now, looking at them together, you might be tempted to say, well, x squared minus y squared is x plus y times x minus y. So if I just use them together, I will have one answer. But I cannot multiply them because the rule says that in order to multiply two numbers, a times b, you need them both to have the same multiple or the same divisor, multiple of x plus a remainder and multiple of x plus another remainder. Only then can you multiply. You say, okay, it's a multiple of x plus the product of the remainders. But in this case, they have different divisors. They have different multiples, even though they have the same remainder. Therefore, it's suspicious because it doesn't meet the criteria. It might be insufficient, but we have to try it with values. When the property does not fit into the problem, it's most likely that it's not sufficient, but you need to try values anyway. So I'm going to use them both at the same time. I need that x and y be multiple of 3 plus 1 and that x minus y be multiple of 2 plus 1 at the same time. Now I have a value 6 and 1 here, 6 and 1 here. The remainder would be 5 in this case. Okay, so I have one set of values that are common. Now I'm going to try to find another one. Okay. For example, if x plus y is 13, then I would have that x plus y is 13 and x minus y is 5. Therefore, if I add them, I would have 2x equals 18, x would be 9, and y would be 4. If I plug them into the question, 9 squared is 81, minus 16, that would be 55. And 55, when divided by 6, the remainder is 1. So I have two answers, 1 and 5. So 2 answers for the question, therefore not sufficient. Answer is E.